Well, we've described preferences and we've described budget constraints. And now we're going to put those two things together and find the consumer's choice. And this is going to result in the individual's demand curve. So let's go ahead and do that. The consumer's goal in these problems, we could say it two ways. Kind of in words, it's to choose some affordable quantities of the two goods, X and Y, that give as much satisfaction as possible. A slightly more technical way to say it would be to say to choose quantities of the two goods, let's say they're F and C, food and clothing, that literally maximize utility, U of clothing and food, subject to the budget constraint, PFF, that is expenditure on food, plus PCC, expenditure on clothing, equals income. So what does that look like? Well, here we have a diagram that has a couple of indifference curves, 3 of them, and a budget constraint, and we have 4 candidate choices. We want to talk about which of those is actually the answer. All right, so just to be kind of complete about this, we have clothing on the horizontal axis, food on the vertical axis. We've got this red line, which is a budget constraint, then these 4 choices. Now, first question we could ask is which of these 4 choices, A, B, C, or D, is most preferred? And I think preferred there may be misspelled. In any event, D is farthest to the northeast. It's on the highest indifference curve, so it's most preferred. However, it's not attainable. It's not on or inside the budget constraint, so D is not the answer. Now, we could consider points that are inside, below the budget constraint, but we know that since more is better, that would never be the answer. An individual would always want to go northeast from there to something else that he or she could afford. So let's not even consider any points that are inside of there. That leaves us with A and C and B. Now they all have the feature that they spend all the money, but they aren't all on the same indifference curve. A and B are on this lower indifference curve, whereas C is on a higher indifference curve. So in fact, C is going to be the answer. And at C, utility is maximized given the preferences and how much money this person has available to spend. There's something else special about point C. Point C occurs at a tangency between an indifference curve and the budget constraint. So to say that another way, at point C, the slope of the indifference curve equals the slope of the budget constraint. One other way to say this, just using some ideas we've talked about in earlier modules, is that at point C, the MRS equals minus the slope of the budget constraint. And just remember, the MRS was minus the slope of the indifference curve, so this is just another way of saying what's being said here. All right, a few more points to make. Stepping back, big picture here, we have a theory that tells us the individual's optimal choices of, in this case, F and C, as a function of the prices and the amount of money, the income that he or she has to spend. Now, those things together work to determine the individual's optimal amounts of F, which we call F star, and in this case C, which we call C star. But taking it back to this diagram, this optimal choice gets kind of projected back to the axes, and here is the optimal C, here is the optimal F. But, those C's and F's themselves are functions of the price of clothing and the price of food, P of food, and income in fully general terms. We'll talk about specific functional forms and get specific answers, shortly. But just at some deep level, the individual faces these exogenous variables that is outside his or her control, the prices of the two goods and how much income he has, and then goes with his preferences and the budget constraints that derive from prices and income to make these choices. And these choices are quantities of food and quantities of clothing. All right, let's talk a little bit more about the intuition of what's special about an optimal point. And as we said 2 slides ago, at an optimal point, the MRS equals PC over PF. And so why is that so? Well, before we jump into the diagram, let's just remind ourselves what the MRS means. The MRS, which is minus the slope of the indifference curve, what it shows intuitively is the individual's willingness to trade off one good for the other. Think about what the budget constraint slope means. That's the market's willingness to trade off one good for the other. And so at some level, the answer is that the optimum occurs when the individual's willingness to trade off equals the market's willingness. But to see that, as clearly as possible, let's consider some points where those slopes are not equal. So let's start at a point like this one right here. And at a point like this one right here, the slope of the indifference curve is steeper than the slope of the budget constraint. Now what that says is the individual, in order to obtain D units of additional clothing, the individual is willing to give up A units. Right? So the individual is willing to give up A to get just D. But the market is willing to give the individual B this amount in exchange for A. So the individual can make himself better off moving in this direction. At this other point, this individual is willing to accept C for giving up B. So this person would give up all this just to get this much, but the market's willing to make a better deal with this person and give this person A in exchange for B, and so the person can become better off moving in this direction. Well, the only place where this is no longer possible is the place where the slope of their indifference curve equals the slope of the budget constraint. And so that's just another way of saying what we've already said, that the optimal solution is at a point where the MRS equals minus the slope of the budget constraint, or here, PC over PF. All right, so now we've derived the relationship between prices and income and these quantities demanded. Okay, quantities demanded, which with these two goods were C and F, and when it was the optimal amounts, we called them C and F star. What I'd like to do is work a little bit with this individual's demand curve to show you how it works as a function of changes in prices and changes in income. Now, we're going to call these movements along versus shifts, and in particular, changes in prices will give rise to movements along, whereas changes in income will give rise to shifts of the demand curve. But let me show you what I mean. All right, so we have an apparatus, and now we're almost ready for the payoff from consumer theory, which will be the demand curve itself. And what I want to talk about is movements along the demand curve versus shifts. All right, so we've derived the consumer's optimal choice as this tangency of an indifference curve to a budget constraint. We're almost ready for the payoff from this whole theory of the consumer, which is going to be the individual's demand curve. What I want to talk about for the next few slides is the distinction between what we call movements along versus shifts. But just as a preview of where we're headed, the demand curve is going to relate the quantity of some good, the food or the clothing or the books or whatever, to the price of that same good. And you can probably guess it's going to have some downward slope. That is, as the price changes, let's say the price goes down, the quantity chosen goes up. Whereas as the person's income changes, we're going to get a shift in the demand curve from, say, a demand curve associated with one level of income to a demand curve associated with a higher level of income. All right, that's a little bit of a preview, but I want to show you how that's all derived from our theory and from optimal choices when one faces different sorts of budget constraints. So here we go. What we have in this diagram is like a two-panel diagram. Up above, we have books on the horizontal axis and a composite good called all other goods on the vertical. where the price of all other goods is 1, and so it's just really measured in terms of income. We see down below, the diagram has the quantity of books on the horizontal, so it's the same horizontal axis as above, but now the vertical axis is the price of books. So that information is all up in the upper diagram, but now we're going to represent it both these ways. What I want to do is kind of a thought experiment where we change the price of books. We lower the price of books from an initial level, P3, and you see P3 appears here, and it also appears here. At this price P3, the individual makes a choice. The optimal choice is right here. Because these diagrams are aligned vertically, we could drop down a dotted line, and where we find this price level P3, there's a red dot, and there's something special about that point. But before talking about it, let's think about a new price level. So now there's a price level for the books called P2. It's lower than P3, so there's a budget constraint that's rotated out. There's an optimal choice on that budget constraint. And here's P2 down below. Notice how it's lower than P3. If we drop down this vertical line, there's that red dot. There's something special about it. I mean, what we're representing here is the optimal quantity of books chosen at a price P3 and the optimal quantity of books chosen at a price P2. We can continue. One more, a lowest price of books, P1, an optimal choice. Drop that down. And what have we got? Well, if we connect these dots, we've got the individual's demand curve for books. And as the price changes, we get a movement along this demand curve. So up above, we see the price falling, and what we see down below is a movement along this demand curve. Now we can also think about what happens when income changes. This is going to be a shift in the demand curve. The exercise here uses the same sort of space, commodity space up above, and this price quantity space down below. But now we'll have two prices and two levels of income. So let's begin with two price levels with the initial level of income, and you can see the associated choices right down below. So we already know that this is a demand curve. But now let's do the exercise again with a higher level of income, I prime, where I prime is, as you can see, bigger than I. So we'll put in two budget constraints that are parallel to the same two lower income budget constraints, and we'll find the optimal choices on those budget constraints. And sure enough, there they are. Now we can drop some lines down vertically. Be a little careful here. And connect those dots. And those dots are the demand curve associated with the higher level of income. The point being that as income goes up, we get a shift in demand. Now here you see when income goes up, demand shifts right. That's pretty intuitive. Technically that happens when goods are normal goods, and we'll talk more about that. All right, so this has been a really crucial module. Here we put preferences together with budget constraints to actually get choices. And that's really the outcome of the theory of individual demand. And what we learned was that the optimal individual choice occurs where the slope of the indifference curve equals the slope of the budget constraint. Another way to say that is that the MRS equals Px over Py. But again, that's a statement about the optimal choice. It's not a statement that's true anywhere in the diagram. It's true at the answer. Next point is that price changes give rise to movements along the individual demand curve, and income changes cause a shift in the individual demand curve.